Hi, and welcome to this new webinar presentation. My name is Alexander Summerall, founder and teacher at This Cobb House, my company that I started in order to help educate people on the use of earth as a building material. This presentation will run about 30 minutes long, and I created it for you as a way to learn about the elements of designing a cob house, because I believe a point that's lacking in our natural building community is the study and importance of good design. The recent natural building phenomena in North America has been mostly a grassroots movement with little to no oversight in regards to design or compliance to building guidelines. And this presentation isn't going to speak on the pros and cons of this, but rather it'll be a means of furthering our education in strong design concepts for those of us who do want to build to codes and guidelines. And if we want there to be a future for cob and earthen construction, then I believe we need to build to the standards set by our society. Not to discount the creative and innovative aspects of earth building, but to combine the best of both worlds, modern construction technologies with traditional materials that make sense for us and the planet. So let's get started by asking the question, who can benefit from having a cob house? We're still a long ways away from seeing cob and earth materials used as a standard conventional material for building construction, and this will take time and proven results to replace some of our conventional building methods. But the point is not to replace everything we have now with cob. Cob is appropriate for certain types of buildings, and our standard conventional materials are appropriate for certain types of buildings too. We just need to be using the right material for the right situation. Cob, as well as other earthen building materials, are appropriate based on a number of variables, and three of the main ones being climate, zoning, and purpose of use. Earth buildings have proven themselves appropriate throughout the world. The only real issue I see is their lack of insulation for very cold climates, and I'll touch more on this later and offer some solutions too. Cob still doesn't have an official building code and is not normally allowed in city limits either, though it could be appropriate for urban or suburban areas if allowed and built right. Cob is appropriate for all types of buildings, small or large. It's very labor intensive though, and would not be appropriate for such large buildings as movie theaters, shopping malls, and other large building complexes like that. These would be instances for other earth materials such as adobe or rammed earth, or to just use our conventional modern materials if they make the most sense still. Now, getting down to it, I think you'll most benefit from a cob home if you fit into one or more of these categories. If you want to live more self-sustainably, want to reduce environmental footprint, want to live in a healthier environment, or if you have chemical sensitivities, or if you want to have all these benefits that earth buildings provide. So, let's look now at some of the inherent properties of earth building materials that can provide us benefits. And the first one is interior temperature regulation. Soil from the earth has proven to be a very suitable and successful building material throughout the world's many climates because of its ability to regulate indoor temperatures. Earth is a poor conductor of heat, has low thermal conductivity, and has high thermal mass. So basically, this means that cob walls can actually store and release heat to regulate the indoor air temperature. And this is going to make your home much more energy efficient and can cut down drastically on your electrical needs if designed right. And the next is humidity regulation. Keeping a balanced level of indoor humidity is important to maintaining a healthy living environment and preventing mold and fungus growth inside. Unlike all other natural and conventional building materials, earth has the ability to balance indoor humidity levels. Earth materials, which are porous, have the ability to absorb humidity from the air and to release it back into the air. This results in a balance of indoor humidity. And in this way, earth walls act as a natural indoor humidity regulator. Next is flexibility and strength. When dry, cob buildings are extremely strong and durable, resembling that of stone or concrete. Fortifications used to be made with cob and similar earthen materials because they were so strong. Bullets can barely penetrate a thick earthen wall, and they're nearly impossible to dig through. Cob homes are very solid and resistant to earthquakes when built on a proper foundation too. Many cob homes have lasted for hundreds of years with minimal upkeep, whereas wooden structures generally survive only a few generations. If you build it right, a cob home will last for many, many generations. Next is healthier living environment. Unlike conventional homes, which are constructed with synthetic, industrial-formed materials, cob homes use more natural, clean materials. Industrial homes are full of indoor air pollutants and off-gassing of chemicals, which are contained in many of the common building materials. Cob homes replace all of the toxic materials used in the walls of a conventional building. In fact, cob actually breathes, so to speak, through its tiny pores and keeps the air fresh and clear. If you suffer from indoor allergies, then living in a cob house could significantly improve your quality of life by eliminating the toxins that may cause them. Earth buildings are a good option for those who suffer from allergies or chemical sensitivities. Cob homes also provide acoustic privacy. Earthen walls have very good sound-absorbing properties that keep it quiet inside, both from exterior noises and noise generated in the same building. Cob homes are also termite-proof. Since cob is a mixture of soil, aggregate sand, and straw, it's not attractive to termites. To add to that, cob homes have not been known to become burrowing grounds for insects or animals either, as long as the house is generally maintained. Cob is also fireproof. Cob does not catch fire, however, still be aware of your ceiling or roof, as it might not be flame resistant like the body of the house. Now, let's venture into the topic of climate. One of the most frequently asked questions raised about cob building is, what types of climates can they be built in? So, the resources for cob, or other earthen building materials, can be found across the whole earth, except for a few exceptions. These would include places where the soil is just too sandy or doesn't have enough clay content. There are usually alternatives to common straw too, if that's not local to your area. So the main environmental factor that could prevent cob from being a valid method somewhere would be the climate conditions. Earth materials perform well in all climates except for ones that have very cold winters. And there may be other exceptions that I'm not aware of, but this is generally the case. It's important to understand that earth materials lack any significant insulation value. Therefore, you either have to make up for it by adding insulation or relying on the thermal mass of the earth materials, passive solar design, and indoor heating. Lack of insulation should not rule out cob as a valid building material in cold climates, though. Proper design will determine your comfort in a cold climate. Another option is to create a hybrid structure. This is simply a building with walls made out of various materials. For example, it's common to build a cob straw bale hybrid in northern climates. The straw bale provides high insulation on the coldest sides of the building, while the cob walls take advantage of their thermal mass properties on the sides of the building receiving the most direct sunlight. So overall, cob is suitable for most climates. We're not talking about a small niche climate range here, in terms of where we can successfully build with cob and earth materials. So now let's look at traditional and conventional materials. People have used earth as a building material for thousands of years because it works very well for the purpose and is locally available. Now, I don't come from a purist type of mindset that natural builders should never use any modern building materials. I believe we can achieve the most by incorporating the best of both sides of the spectrum, to use modern building materials where they're appropriate and make the most sense, and to use earth materials or natural materials where they are appropriate and make the most sense. This way you get the most advantages out of your building's materials, and it also paves the way for more acceptance of earth building in the modernized world. Okay, now I'll talk about the main components of a cob house. And these components apply to almost any type of house or building. Of course, we start with the foundation. And the foundation is a solid base upon which your building rests. No building will be strong and stable unless a foundation is first. I've seen too many cob buildings with very poor foundations, and that's why I'm going to stress the point that you need a good foundation. Don't skimp on the foundation. This should be one of the most time-intensive parts of your building project, in my opinion. The design, planning, and construction of the foundation is a huge part. And this is why I advocate mostly for modern conventional foundations when building any kind of building. Traditional and alternative methods have a lot more room for error, or they're just not up to quality standards sometimes. In my cob house designs, I now always implement a concrete foundation. This will provide a solid footing and stem wall. It will also pass codes in most cases, so you can get through on that step. And a good foundation also needs a proper drainage system, since water is especially damaging to dry cob walls. This is another aspect of a foundation that needs to be designed right, with a good strategy for collecting and diverting water away from the building. This is normally done with gravel trenches and drain pipes around the perimeter of the building and underneath the foundation. Roof gutters and spouts directed away from the building are also good to have. Now, moving right along, on top of the foundation go the cob walls. And of course, the windows and doors get built into the cob walls as the walls rise in height. There are many variations of how to install windows and doors into cob. Normally, they're set into a wooden frame, and then the frame is attached to the cob wall by pieces usually termed as dead men. And these dead men act as anchors, as they're completely embedded inside the cob walls. And then the windows or doors are drilled to these embedded anchors. So now, once you reach the top of the cob walls, whatever height that needs to be, this is where I encourage the use of a bond beam. The bond beam is the point of attachment for the roof of the building. It has anchor bolts embedded into it, which are used for attaching the top plate, and the top plate is what the roof is then attached to. And the bond beam also acts as a tension ring that ties all the walls together into one monolithic piece. A bond beam creates a stronger wall system, and it's good for earthquake-prone areas as well. The roof can also help tie the walls together by its strength and connection to the bond beam. This creates a uniform distribution of earthquake loads onto all the walls of the building, rather than just to those which are perpendicular to the direction of the ground movement. So the bond beam is also made of concrete and reinforced with rebar. So you get a stronger building and an easy way to attach your roof. And yes, it's a bit more concrete, but I do believe it's worth it. These concrete bond beams are also very common on rammed earth buildings. And again, this is another helpful way to hopefully get building approval if you're going that route. And next here, I'll touch on the subject of electrical and water lines in regards to cob building. And these concepts apply to earth building in general. Water lines should never be run inside of cob walls. It's just too much of a risk. A broken and leaky pipe will be a disaster for any earthen wall. That's why I recommend running water lines in and out underneath or through the foundation, and then running water lines underneath the floor to get to various parts of the building. Electrical lines are different though. These can be run through cob walls. Since cob is not going to catch fire, that's not a risk. I recommend running electrical wires into cob walls through metal conduits. This makes it easier to feed wire through the wall and repair any wires later on. And so now that we've covered these basic building components, that leaves the roof as the other big piece. And the roof is made a lot easier if we just use the modern bond beam, the concrete beam that sits on top of the cob walls. From this point, all you do is build a conventional style roof with regular conventional materials, and it attaches right onto the level bond beam. And this might not seem like a great idea or very innovative, but it's actually the best way to attach a roof in my opinion. There are many methods that people have developed for attaching the roof, but they're more difficult to construct, not as strong, and less code friendly. They also add to the learning curve for new builders, I think. For example, some cob builders advocate running the rafters through the cob walls, but this really creates a nightmare for roof building. I just as well advise you not to try that route. Add a proper bond beam, then you can simply attach any kind of roof that you want. using normal building methods. No extra learning curves or difficulties involved this way. Okay, so the roof is obviously important for keeping the house dry, and that's what I'll speak on next, how to weatherproof and keep the cob walls dry. As far as the roof goes, it basically needs to have overhangs on the sides to protect the walls from rainfall. The other ways are, again, to have a good drainage system around the building and the foundation to collect and divert water runoff away. And the third main part is to have an exterior finish on the cob walls. This render acts like a kind of skin of protection from any moisture damage. Alright, so now that we've looked at the building components, let's turn our attention to another frequently asked question. And the question is, how big can a cob house be? So technically a cob house can be as large as can be imagined, though cob does have some restrictions on height, at least for the average builder. But in terms of normal house sizes these days, yes, anything is possible within that spectrum really. But the size of your house or building is going to depend on a whole list of variables, as with deciding the size of any kind of building. And the same goes for cost. There's no way to say how much a cob house will cost based on square footage or anything like that, because there are just too many variables involved with it. Somebody could build a 1,000 square foot cob house for $30,000, and another person could build a 1,000 square foot cob house for $300,000. Costs will depend on such things as labor costs, quality of materials, style of building, inspections, whether you have architects and engineers involved, meeting certain regulations, and that's just to name a few. So, now with all that said and done, what does the future hold for cob and earthen building methods? And I personally believe that with the direction that things are going, cob, and when I say cob here, I mean earthen building materials in general really, cob has a big place in the future of building. For starters, it's an environmentally conscious building material. It's more economical, and it's a healthy alternative to toxic, industrially produced materials that we normally use today. But despite the overwhelming advantages of such a material as earth, there's still a tremendous amount of work and scientific testing that will need to happen before it can take its place as a mainstream building technique. For example, soil is different everywhere. This is a nightmare to try and standardize and conform a system to, and it can take a keen sense of the soil composition and testing to determine if it's suitable for building with sometimes. Official building codes will have to be established as well. This takes a lot of money and time. However, cob is available for us now, despite the restrictions that can occur, and we still get to be the pioneers in this story. That's one of the main goals with my business, this cob house, is to try and show by example what's possible with earth materials for the average person. I also want to bridge the gap between traditional earthen materials and modern conventional materials. I believe they do create a perfect marriage together. In order to create modern, stylistic, clean, healthy, and harmonious buildings that will stand strong through many generations. Alright, now I'll take you through a basic checklist for building a cob home. So building a home is a major undertaking that will cost you a lot of money and time. It can be like putting together a large three-dimensional puzzle that has to be able to interact with the environment and the conditions around it. Building a home is a lot of hard work, both physically and mentally, and will require you to use a variety of skills. So the more skills and knowledge that you bring to the table, the fewer learning curves you'll have to overcome. But there will always be challenges and complications. Another thing is, you'll have to learn to work with others throughout your building process. Even if you build your home by yourself, you might still have to work with designers, structural engineers, and building inspectors, or just your friends helping you. Next is to develop a vision. Set a vision for what you ultimately want to achieve with your building. Only you can know what you want, but it's a good idea to think logically and realistically when deciding what you want to build. A lot of people's ideas become very extravagant and out of proportion with what they can realistically accomplish. so it's important to keep it real. And next is site selection. The site that you choose for building can have a large influence on how efficient it is and how it will be preserved over time. There are many aspects to consider for selecting a proper site, which this presentation won't be covering, but you need to find a good site before you can put together a detailed design plan. The site can strongly influence the design and function of your building. And next is to estimate costs. Be realistic and conservative in your cost estimates. At least that's what I do for my projects, because it almost always turns out to consume more time and money than I originally planned for. The ingredients for cobb are cheap, but account for everything that you'll need. Foundation materials, roofing materials, windows, doors, electrical, plumbing, tools, machinery, transportation, subcontractors, permits, etc. They all cost a lot of money when added up. So don't lose sight of reality and expect to build your cobb home on the cheap just because the walls are made of cobb. And next, of course, is design. Designing a building is an art and a science in itself. The way that you lay out the floor plan for your building will be what you have to live with once a building is built. So put intelligent thought into your design. You may want to consult with a professional builder or interior designer before going forward with your plans. They can help pick out the faults in your design and offer valuable solutions for you. And this next one's important too, is to have planning and timetable. Make a game plan for your project and set a timetable for building your structure. You should plan out each phase of the building process according to the seasons, your financial situation, and materials availability. For example, you might not have enough money to complete the whole project at the start, but you do have enough to build the foundation. So you might plan to build your foundation during the winter while it's cold and unsuitable for cobb building. Save money during that phase, and then be ready to do the cobb work when it warms up in the springtime, and have money for the next phase. And then the last one, and one of the most important points in the checklist, is education. You need to begin to thoroughly educate yourself on building with cobb or whatever type of building material you're going for. Whether you're building it yourself or having somebody else do it for you, you need to know how everything works and integrates together. You can never get enough education about building, but at some point you're going to have to start if you want to have a house. However, I would recommend more education and learning experience rather than rushing into a building project. It may take you a few more years of preparation before constructing your dream home, but it can be well worth it. Start reading books on cobb, natural building, sustainable energy systems, and whatever else interests you for putting together a home. You might have to learn a whole new set of skills. Also, try to take classes and workshops to gain confidence with these new skills. I really can't stress the education and learning enough. That's why I put so much work into creating these educational webinars, writing articles, books, and making videos. I want people to have the knowledge and understanding to build with cobb, without going through all the hoops and learning curves that I did. And one of the places that I see people having the most trouble with is in design. So that's why I've recently put together a design course for you focused entirely on cobb building. And this is your chance to get access to this new course. So in a nutshell, this course will teach you how to design a modern, high-standard, more code-friendly cobb house. No other workshop, book, or video anywhere else has laid out the fundamentals of cobb design like this new course does. I really think it's a unique opportunity, and you won't get this much design information even if you took 10 cobb workshops. So this class is delivered in an online format, and you'll receive all the learning materials as soon as you join. And the class is composed of these 3 parts. Video lessons. So you can watch the instructional videos leading you through each design component. And there are also construction diagrams. You'll get over 100 pages of carefully detailed construction diagrams with the course. And there are also design notes. You can also download these notes associated with each lesson for even more design specifications. And lastly, you can receive the tiny cobb house plans. These include 30 extra design diagrams. And whether you even want to build the tiny house, these designs are a wealth of knowledge that you can learn from to design your own cob building. And more specifically, here are the building components that you will learn about in the course. Learn how to build a strong foundation with proper drainage that can meet building codes. You'll learn how to integrate electrical and plumbing lines through a cob building. You'll learn how to securely install windows and doors into cob walls. You'll learn how to form a bond beam to connect your roof and tie your walls together. You'll learn how to integrate a second-story floor system into a cob building, and you'll learn how a roof is structured and attached to a cob building. And you'll learn how to build a tiny cob house. So to speak a little bit more about the tiny cob house plans, you'll get the detailed building plans for this 12 by 24 cob house. And whether you want to build this structure or not, the plans are just a wealth of information for building any type of cob building. The plans include 30 extra pages of building diagrams, and you'll also receive the SketchUp file so you can explore and edit this model. These building plans include everything you need to construct this building. Okay, so why should you join this course? And firstly, I'll say that if you have an interest in building a cob house, or any kind of house for that matter, then this is definitely a course for you. While this course is based on using cob, these design lessons apply to many other natural building methods too, such as rammed earth, adobe, earth bag, straw bale, and light straw clay. And I guarantee you won't learn these important design lessons at any other workshop. I've compiled some of the best design lessons all in one compact course from years of research and experience. These lessons can literally save you thousands of dollars in building mistakes. It could even save your house from a structural disaster. An architect or a natural building design consultant can cost you hundreds or thousands of dollars for a single visit and consultation. And not to say that this is bad and that they're overcharging, not at all actually. One visit by a professional designer might cost you $500, but it could save you $50,000 in mistakes. And this course has the potential to save you thousands of dollars in the same ways. And whether you're working with a professional designer or not, you personally need to understand the fundamentals of designing a cob building. Here are some of the benefits of doing this course. You get access to the only design-focused cob workshop. You'll learn how to avoid the major design mistakes with cob building. You can potentially save thousands of dollars in architect and consultancy fees, and there's no travel required. All you need is a computer with internet access. There's no need to use your precious vacation days to attend a workshop, and there's no need to cut time out of your busy schedule. And as an added bonus for signing up for the course from this webinar presentation, you get both of my ebooks that cover cob building and building codes. And on top of that, I also want you to know that because I value you as students and customers, that there's no risk in signing up and purchasing this course. You're protected by my 30-day, 100% money-back guarantee. If you're not satisfied and within 30 days of signing up for the class want a full refund, you will be refunded. I made this program for you, and I'm committed to delivering you with valuable learning content here. I want you to feel comfortable and satisfied with taking the course. So in just a second here, I'll display a link for you to click on, where you can join the course. So when you click the link, you'll then be directed to the page where you can select the course package that you want. Select which pricing option you want, and then you'll be directed to the secure checkout page where you can make your payment via credit card or PayPal. And then once your payment is made, you'll receive a confirmation email within a few minutes of processing your order. This email will include your login information and tell you how to access the materials. Be sure to check your spam folder if you don't see it. Sometimes it goes there instead for some reason. So at this point, if you'd like to join the design course, just click the link below and sign up. Also, if you have any questions about the course, there's a frequently asked questions section on the page. Just click that same link. You can also email me at alex@thiscobhouse.com. So there we go, and I wanted to keep this webinar a bit shorter than usual, as I know how precious everyone's time can be. So, I do hope that you all enjoyed the presentation today, and I hope that you'll take a look at my new design course. This cob house is only able to stay active because of active participants like you, so I appreciate every student that I have. So now, until next time, wishing you all the best in your building endeavors, or whatever it might be, permaculture, organic gardening, off-grid homesteading, just all around health and freedom, because that's what this is really all about. So to everyone here, have a great day, and I'm signing out. See you next time.